Hopefully you guys can hear and see me okay. So again, my name is Alina and I work as a Science on the Sphere presenter here at the MSU Museum. The museum, if you haven't interacted with us before, is a science and culture museum, and today we're going to be talking about science with our Science on the Sphere, and about how science can solve mysteries. And our mystery today is how a penguin feather from Antarctica could wind up on a beach in California using scientific data. So our Science on the Sphere was developed by NOAA, the National Oceanic and Atmospheric Administration, and the image you see here is projected by 4 projectors, which you can't see very well because we're in a virtual webinar right now, but from the corners of the room. So it's a super cool piece of technology, and if you guys have any questions about the sphere, we can definitely take questions throughout the program and then again at the end of the program. Alrighty, so let's get started with the program. Yes. All right, so the first data set we have is a little bit of a video, and if you can't hear the audio, that is okay. I will let you know what you missed. I can't hear the audio either, so it's coming. Beach. Ew, that shoe. Wonder how long it's been floating around that. Hey everyone, thanks for all your help today on the beach. Let's bring back up the picnic area so the trash won't recycles. Hey, I found this boat on the beach. You study birds. Can you tell me what species they came from? Well, most of it are seal. This one looks really interesting. It looks to me like a penguin. Penguin feather out on the beach? How could that be? So we've got our introduction to our mystery here. So there was a beach cleanup, and they found some shoes and some trash, which none of that is good. And then they found some seagull feathers, which is to be expected, and then they found a penguin feather, which is not what they expected. So the mystery that we're going to be solving is the mystery of, could we find a penguin feather from Antarctica and a California beach? All right, so to start off figuring that out, does anybody have, let's see, okay, no. We're going to start off with our demonstration. Yes, okay. Yes, do you have a question? That's what I was going to ask. That's okay. Alrighty, so move the camera real quick. Whoop. All right, we've got our demonstration table here and our trusty penguin audience here. It's our only live audience here in our Science on the Sphere gallery today. So here we have a tub full of water, and the water represents the ocean, and the ocean, no, and the rocks represent the different continents of the Earth. And you're only going to get a view of the tub right now. The penguin, I don't know that the penguin has a name. We could give it a name if you guys want to. We could start a penguin naming contest in the chat if you guys would like. Okay, so for this demonstration, like I said, we have the ocean as the water in this tub, and then we have the continents as the rocks. So with this, we have this food coloring, and we're going to take a few drops of food coloring and we're going to put it in here and see what happens. That was cool, but not a whole lot happened. It just kind of plopped down there, right? It still looks really cool. Whoa, okay, I don't know what's going on there. But it's just plopping down, not a whole lot going on. Alrighty, let's see what happens when we add some ice cubes. So I've got a bunch of ice cubes down here. Ugh. Dump a bunch of them in there. All right, so you added a bunch of ice cubes, and these ice cubes are gonna melt, right? Let's add, you can already see that something else is happening to the dye right now. We'll add a few more drops. So the dye isn't just plopping down and staying in one location, right? It's moving around, it's kind of dispersing, it's moving in directions. Watch what happens when it hits the continents, like right, the rocks, the cups. There's green on my fingers. Oops. It's gonna go around them, right? Kind of move around. So what's happening here is that as the ice cubes melt, the cold water is denser. There's more water molecules packed into a smaller space, so it drops to the bottom, which creates these kind of currents. There's movement of water that kind of moves the water all around the pan, around this representative ocean that we have going on here. Yeah. So we've got this flow going on, and this is going to keep cycling around vertically and then again in this kind of horizontal space as well. So again, this is a model of what we have going on in the oceans. And if you guys would like, we actually have instructions of how to do this at home on our website. So if you guys want to try this later, you definitely can. Alrighty, we're going to talk about how this relates to our oceans in a moment. All right, let's bring this back up. Okay.
Alina, while you're setting things up, we do have one question. Just while you're setting things up, we can answer it. And it asks if it's the warm water that moves on top then, compared to the cold water in the container.
So it's gravity kind of that's pulling the colder water down. So it's more the sinking motion. That's kind of, so it's kind of the rising up, but it's more the sinking that's kind of, it's pushing the warmer water up, I guess. Yeah, but it's the sinking that's kind of displacing the warmer water. Yeah, because you can have both waters existing in the same place. And then as the mixing occurs, the cold water will warm up, and then, you'll get the whole cycle happening all over again. And then in the oceans, you'll have more ice melting and more water warming and everything. So it's this whole cycle that we're going to get into in more detail in a minute as we go on here. Hopefully that answered the question. Hopefully, let me adjust this a little bit more. And I think we can go this way and that way. A little bit more. There we go. Okay. Do we have any more questions?
They also had asked if adding the ice, adding ice cubes faster or slower makes a difference. I don't know the answer to that, but I did include a link to the activity in the comments. So if you guys want to check it out and try it out on your own, I think that'd be a great experiment to try to see if adding more or less ice changes it.
That would be a great experiment to try, yeah. We're all into scientific investigation here. Yes. Alrighty. So we have only seen one Science on a Sphere data set so far. Let's get into a few more. Alrighty. Okay, so just like the, we're fine. Just like the pan of water, the water of the oceans, they're not, spin, there we go, okay. The water of the oceans aren't totally, they're not all the same, slight technical difficulties, there we go. They're not the same temperature all around. They're gonna be warmer at the equator around the middle and then colder at the poles. So the cold water of the poles is denser, it sinks to the bottom and then starts to move towards the equator. And then that creates these large-scale deep currents. These currents are responsible for moving large amounts of water from one part of the world to another, like the currents in the pan are moving water around the, it's not a pan, the bucket. Yeah. All right, so if we look at the data set, stop it spinning. Does it seem like there are any currents that could take a feather from Antarctica? So down here we have our penguins down here. Does it seem like there are any of these large currents that could take a penguin feather from Antarctica up to California? Put that in the chat. If anybody has a guess. I think it's close, right? Maybe not quite. We're a little far here. Maybe get us to like Hawaii. Yeah. So these thermal currents, yeah, so there's a stream that could, there's a current here that gets us near Hawaii, but not quite to California. But these aren't the only currents that we have. Differences in water temperature aren't the only things that create currents. A wind blowing across the surface of the ocean also creates these currents through surface currents. Sorry, they're called surface currents. Through upwelling. Those are here, bring around to California. So these are a lot closer to the coast of California here. All right, so here are some of the major wind-driven currents. So does that change your thinking about whether the penguin feather could get from the Antarctic up to California? Again, thinking about, so we had that one current that could get us to Hawaii, and then we have these wind currents that get us pretty close to California, but maybe not directly from Antarctica. Let's look at them together. There's a lot going on here, but that's kind of the point. There's a lot going on the Earth. So it might not seem, so we have all our penguins here at the bottom, and we have all these currents. The thermal ones are the large ones, and then we have those wind-driven currents. So looking at all of this, do you, put it in the chat, do you think that a feather could get from Antarctica all the way up to California? Looking at all of these. If you want to see a different part of the map, just let me know. That is a good point. So penguin feathers float. How could they be moved by deep currents? So that is a good point. Penguin feathers do float, but I think it could get pulled down pretty deep. If it did float, though, it would get caught by these wind currents. which could definitely pull it more into this whole cycle of currents. Well, it ended like the blue ones. And then I think it's definitely more plausible that it could get up to California, at least that's my thinking. But yeah, that's a good point. What if the feather was frozen in the ice, which eventually melted in the ocean? That is also a good point. Feathers might get stuck in things. In what condition was the feather? That is also a good point. I don't know if this was a hypothetical feather or an actual feather, but things like this do happen. It's probably not in great condition. We'll talk about that more in a minute. So from what we're seeing, let's look at this next data set. So this data set, we're going to take a look. There's a penguin generating feathers down here. And those feathers are going to take a trip up this thermal current and then across these wind currents here. And they're going to end up in California. So hypothetically, it could happen. A feather could go from California all the way up to, could go from Antarctica all the way up to California. So it could take a really long time for that to happen, maybe hundreds of years. So that feather would be in not great shape. So it's possible, but maybe unlikely that this would happen. But we can apply this to just objects in general placed in the ocean. If an object placed in the ocean anywhere, if an object is placed in the ocean anywhere, could it end up anywhere in the world if it was allowed to float around in the ocean long enough? Hopefully that makes sense. All right, so I'm going to bring up a data set that is a very long data set. I'm going to bring it around to what we're actually looking at. All right, so this is the particle that we're looking at. Just keep that in mind. All right. So scientists have run simulations to see what happens when you add an object to the ocean. This is important in thinking about what happens to pollution when it gets added to the ocean, about oil and plastic, all that kind of stuff. Is it contained to an area? Does it spread? How far does it spread? So here we have a sample particle and it's escaped. Come back. Okay, it hasn't escaped that far. Here we have a sample particle added to the Pacific Ocean over by Oceanic to begin with. So we're going to run a simulation and see where it ends up. We're going to fast forward a little bit because otherwise we would be here for like 20 minutes watching it go around in circles sometimes. So we're still over here in kind of the Asia, Africa area. Now we're on the other side of Africa, over here in the Atlantic. Okay, so we're at about 66 years of the simulation. And it's made its way up to like the mid-Atlantic area. This data set is about 500 years, so we're going to fast forward a little bit. It got caught on the islands. It's going to take a couple of loops around the Atlantic. It gets caught in a current here, and then it heads up north. We're at 125 years now. Heads up north, goes around some islands. It's stuck for a minute. Fast forward a little. Alright, loops around, comes back down. We're at 250 years now. Just think about where it's been so far. Fast forward about halfway through the data set. Comes back down the coast of South America, the eastern coast. 350 years. This is Antarctica. It's gonna loop around Antarctica a couple times. There's this current that traps the Antarctic. And it's gonna go around that a couple times. And then we're gonna go back up. I'm not gonna make the planet upside down. It gets confusing. But we're by New Zealand now. And we're at 425 years. And then 450, and then zigzag its way across the general Pacific until about 520 years, until the end of the simulation. So, if we let this, if we look at this, we can see that in about 500 years, the particle basically just zoomed its way around the entire Earth. So we say that there's like, you know, the 7 seas or a bunch of different world oceans, but they're all connected. It's a bit of a misnomer. And you can see that any particle, anything that ends up in the ocean is going to make its way around the world. So whatever we put in our water here, it's going to end up in the ocean, and it's going to end up going pretty much anywhere. We had a few comments I saw. Yes, shoes are washing up on the shores. That is not a hypothetical thing. Shoes wash up all the time. Everything washes up on shores. Yeah, so I don't think this simulation took into account, you know, polar melting or anything, or climate change. It just kind of like took into account land masses, like continental shelves and stuff. So it was just looking at the currents and how they are right now, and how the particle will move through those currents. Yes, the shoes. Yeah, so this wasn't an actual feather. This is just a simulated particle, but if it was an actual feather and it lasted 500 years, that'd be very impressive. The issue with 500-year lifespan is that things like plastic would actually last 500 years in the ocean without breaking down. So that's not great. Alrighty, does anybody have any questions about this simulation before we move on? Talk about penguins a little bit more? No? Okay. Alrighty. Let's talk a little bit more about penguins and their relationship with these ocean currents that we've been talking about. So when we talk about penguins, most people have a kind of, oh, we have a question. So how do the plastic islands form with all that current moving things around? Yes, so with all of the currents, there are these kind of places in the oceans where the currents kind of form these circles where things get trapped. They're called gyres, G-Y-R-E. And it's actually a really cool data set that we posted a video about over the summer that kind of simulates where like plastic particles end up when they're in the ocean, and they kind of end up in the same places every time. So I don't know the name of that. Maybe Nick could find that and put it in the chat maybe. But there's, yeah, they kind of get stuck. The currents kind of corral them into the same locations a lot of the time. So particles could end up a lot of places, but they tend to end up congregating together. Yeah, Nick. Oh wait. Nick, I think you sent that to just me, so maybe send it to all attendees. It says direct message. All right, can those stuck plastics then be vacuumed up? So there are a lot of projects that are trying to come up with those things, but the issue with vacuuming stuff up is that we also don't want to vacuum up the things that live among the plastic, like fish and various other sea life. So Scientists are trying real hard to come up with different cleanup strategies for plastics. Alrighty, yep, there we go. Alrighty, okay. So let's talk about the penguins and their relationship to the currents. So when we think about penguins, we kind of have an idea in our head about what a penguin looks like, kind of a general idea, stereotypical penguin. So when you think of a penguin, what do you think about? Do you like what color are they? How tall are they? What's a penguin species that you're familiar with? And where do they live? You put an answer to one or a couple of those questions in the chat. Again, like species, colors, size, where they live. Daddy penguins. Nice. Cute fuzzy birds. They are fuzzy for birds. Yeah. They're not mammals, but their feathers are fluffy. Yeah. Little black and white tuxedos about knee height. Yeah. Yeah, that's about right. That's what we think of. Penguins at Potter Park. I don't remember which ones. Are they African or Magellanic? South American. Galapagos penguins? They might be Galapagos. Magellanic. Okay. Thanks. Nice, we got some penguin diversity in the chat. All right, so there are about 25 species of penguin all over the world, and we're going to bring up a picture of all of their ranges. Once I find it. There we go, okay. We're gonna see if the sphere can adjust in a minute. It might. Only in the southern hemisphere. That is generally what we think of. Yes. And if the sphere would adjust, then we could see their range. One moment. That did not help. Okay, slight technical difficulties. But if we could see this picture of the penguin's range, then we can see that they are mostly located in the southern hemisphere and located along the coasts of the places where they live. So located along the coast of Antarctica, along the coast of South America, along the coast of southern coast of Africa, Australia, New Zealand. I'm gonna take away this and I'm gonna point at things instead. Yes. So down here and here. Nick put an image in the chat. I'm guessing that's the range map that we can't see. So, thank you for that. Yeah, it showed up the other day. I'm not sure what's going on. Alrighty, I can see it, but that's not helpful for you guys. Oops. Alrighty. So, one thing that a lot of people don't expect when they see a map of where penguins live is that some penguins live right near the equator, and we'll talk more about them later. Okay, so There are a wide variety of penguin species, and you guys put a lot of those in the chat actually. But today we're just going to be looking at 3 of them and how they interact with ocean currents. And they're actually none of the ones that you mentioned. So we're going to be looking at the emperor penguin, the little blue penguin, and the Galapagos penguin. So you can put your answers in the chat. I'll put a picture. No. That one. Yes. Okay. So here we have a picture of the emperor penguin, which is probably what most people think of when they see a penguin. We actually have in our studio audience today an emperor penguin. But where do you think emperor penguins live? Yes, the happy feet penguin, exactly. So where do emperor penguins live? You can put that in the chat if you know it, or if you have a guess. Antarctica. Yes, exactly, thank you. So emperor penguins are found in Antarctica. They're kind of the stereotypical penguin that we always think of. And that is their range. So again, it's kind of the weird look at the Antarctica that we don't always see. And again, we're having a little bit of an issue looking at the range that we weren't having last week when I checked to make sure we could see these, but that's okay. They are found in Antarctica, and we're going to put them down at the bottom where they're supposed to be. Alrighty. Our next penguin that we're going to look at is the little blue penguin. The emperor penguins are the biggest penguins that we have. The little blue penguin is little and blue, and not showing up very well. I'm not sure what it is today, but it is very small, and you can see you might be able to see there is some green in this picture. The little blue penguin is like this tall, about 6 inches tall. It's standing next to some blades of grass. It is slightly taller than the blades of grass. So does anybody know or have a guess as to where the little blue penguins live? Southern Australia and New Zealand. That is exactly correct. Yes, you must be a very big penguin fan. All right, so these are the smallest penguins in the world, and I'm going to add them to where they live. So that, and there we go. They're where they belong. All right, so our last penguin that we're going to talk about in a little bit more detail today is that surprising penguin. So the Galapagos penguin, their name kind of gives us a hint if you know what the Galapagos are. So the Galapagos penguin, that's this guy right here. They look pretty similar to a lot of other kind of penguins that live where they close to where they live. But does anybody know where the Galapagos penguins, where their range is? I know, it's hard to see the pics on the sphere. I tested this out earlier and it was totally fine, and I'm not sure why it's not currently totally fine, so I apologize for that. Yes, the little blue penguins were something smart. Any guesses on the Galapagos penguin? It is currently moving behind them. The continent where they live is currently moving behind them at the moment. Ecuador and the Galapagos. Yes, thank you, Jessica. So they do live on the Galapagos Islands off the coast of Ecuador in South America. So we will put them where they belong. So the Galapagos penguins are the only penguins that live above, they're like slightly above the equator. So someone said earlier that the penguins live in the southern hemisphere, which is generally true with a very, very small exception. And that is partially due to something that we have talked about earlier today. So the Galapagos Islands are north of the equator, where it's very warm generally. So based off of what we learned about earlier, how can penguins survive there without getting too hot? There's really only one thing we discussed earlier, and the general topic of today's talk. You put that in the chat. How can penguins survive in the Galapagos? Yes, sorry, I can repeat the question. So given that the Galapagos Islands are very warm, how can the penguins survive there without getting too hot? It's related to what we learned earlier. Their feathers are not as insulated, so that's part of it. Yes, so are they near a cold current? So that is exactly right, yes. So ocean currents. So part of it is that they have adapted to live in a slightly warmer location, but the other part of it is that it's the Humboldt, or as our next dataset calls it, the Peru current, runs from Antarctica up to South America. And if the current is running up from Antarctica to the Galapagos, do you think that the water is cold or hot? Put that in the chat. So the question is the water coming up from Antarctica to the Galapagos cold or hot? Yes, we have some colds. Exactly, the color of the arrow might have helped with that. So the cold water of the current makes the area around the Galapagos much cooler than you would expect. So it can still get hot there, but not too hot for the penguin, especially as they adapted. So the ocean currents act like a circulatory system for the Earth. They kind of mix the water around and make the climate around the world kind of more even. Like we saw from the simulation, they can bring cooler or warmer temperatures. Alrighty. Let me bring up one more data set for today. I have to find this one. Make it spin. All right, so ocean currents help move cold and warm water, but they're also affected by changing temperatures. So I have one more question for you guys. Well, second to last question, I think. So what do you think would happen to ocean currents if everywhere on Earth was the same temperature? Would the water still move around? So like we saw earlier, when all the water in the bin was just at one temperature, nothing happened to the food coloring, but when we added ice, the food coloring moved. Yeah. So no, at least not as much. So the wind would still blow, the wind would still move it. So the wind would still have those currents, but the deep ocean currents are very important. The ocean is thousands of meters deep, and those surface wind currents really only move a little bit of the water. So we have a little bit of movement, but not a lot. And yes, that would be terrible for animals living in the ocean. And ice does cool the water. So the situation that we're currently in, so ocean currents exist because of temperature differences. So if all the ice at the poles melted, the ocean currents would stop. We wouldn't have that temperature difference because the ocean currents are currently driven by the heating of the water at the equator and the melting of the ice at the poles at a small rate. And it's like cyclical. So the situation we're currently in is as global temperatures change due to increase CO2 and other gases in the atmosphere and the melting ice caps. It changes how the currents work, and that affects penguins, but it also affects the weather, the climate, and ultimately us. So we don't want that to happen. So we've got a lot of, we've talked about this a lot in our other webinars, but there's a lot that you guys can do to kind of help change that. You can talk to the people in your lives about the different industries and reducing, greenhouse gas emissions and our impact on the environment, and just, being more environmentally minded people. Does anybody have any questions about currents or penguins or any data sets you want to see? We named the penguin Bob. Is that with a general consensus? I think there was just one suggestion. I think we can name the penguin Bob. Yeah. This is my favorite data set, in case anybody was wondering. You probably weren't, but the red, the warmer colors, the red shows the warmer ocean temperatures, and the blue, purple shows the colder temperatures. This is a simulation of the kind of more detailed ocean currents that are going on. It does look pretty, it does. The nice thing about about a lot of these data sets, especially simulations, is that you can make them look really nice, but they can still be really informative, which is part of what is really awesome about Science on a Sphere. The gyre data set. I'm not sure if it is on here, but I'll check. I think that might just be an SOS Explorer data set, the gyre data set. Cool. So I would show the gyre data set with the different plastic particles, but I believe that it's only available in the SOS Science on a Sphere Explorer app, which is available in Android and Apple app stores. So if you guys want to check that out, I would definitely encourage that. It's something you can do on your own phone, in your own home. Were the currents bringing heat and station across the ocean, currents or wind? Nick, I think that was another direct message. Yes, it was Explorer. Yeah, there you go. So sailors, I believe, use both wind and water currents, but I am not a sailor, so I'm not sure. We can bring up the, we're having a keyboard issue. This data set. So this is the more like large kind of general water currents. Stop spinning. Stop it. And there are definitely a lot of large ones kind of involved in, trade currents, I guess, across here. But I'm not exactly sure. How about they were in sailing trade? The Gulf Stream went up there. That's important in regulating the climate of the kind of the eastern coast of the US, but also Europe. That's why kind of Great Britain is warmer than you'd expect with it being so north. Another question? What kind of current disperses the radioactive particles from Fukushima? I think that would be an air current. Let's see. So this one doesn't show dispersion of radioactivity or radioactive particles, but it shows dispersion of other particles through the atmosphere. I'm back on the screen. There we go. So it shows sea salt, sulfate, organic carbon, and dust. There's different types of kind of air particles or pollutants. And this is also available in the SQS Explorer app. And we may have a video explaining it already posted. But it shows like the different dispersal particles across the world. It's a super interesting data set to look at. So you see like sulfate kind of spiraling away from China, Eastern Asia here, moving across there, kind of across the Pacific Ocean there. Just moving across the Sahara. Organic carbon moving off the Amazon. Sea salt and sulfates moving across the Northern Atlantic. So yeah, that's like an atmospheric thing, I would think. Okay, any other questions? Radioactive ocean. There is a radioactive ocean. Radioactive. There's a Fukushima radioactive ocean and a radioactive aerosol dispersion one. Yeah, so the dust from the Sahara, it has sound.
Nearly 16,000 people lost their lives.
Yeah, so the dust from the Sahara does acts as a fertilizer for the Americas. Yeah, the particle exchange across the Americas and like the Sahara is super interesting. And we're learning a lot about that. I've never seen this data set before. This is the Fukushima radioactive ocean one. It's a video. Yeah, Nick, thanks for putting the video in the chat. If the image is hard to hear to view, sometimes the audio would definitely be worse. But there is a aerosol dispersion model that is not a video of Fukushima. So, yes, there we go. So there's it's like the red is more radioactive and the purple is least radioactive. Ooh, that's a lot of particles. Many particles. Yeah, that is scary. My high school physics teacher, we had a day or two, we had like a cancer unit, and he basically told us that every day we're exposed to radiation, which was scary, but it's also kind of a fact of life at this point. So, yeah. Huh. At least it's colorful, right? So not all of the data sets that are available on this sphere are available in the on the app. So the app has like 100 or so data sets. Our sphere has a couple hundred, like 600. I don't know the number. This sphere has a lot more data sets on it. It's got more capabilities. but the app is still very cool. And there are some datasets that are available on the app, but not in our sphere. So, yeah. Alrighty. Well, yes, the app is constantly being updated. Any last questions before we have to wrap up? If not, thank you guys so much for attending our webinar. You guys have been a great audience. You had so many great questions, and you guys were very interactive. And I hope you guys have an awesome rest of your day. Oh, wait, goodbye to Bob. Yes, I will bring Bob to say goodbye. See Bob? Let's see. Goodbye to Bob.